All right, welcome to 3.3. I think y'all are going to like this section. This is going to be a nice, pleasant surprise, I think. Sometimes I'm wrong. We'll begin this video by making a comment on the green screen. Guess what happened to it? Guess who happened to it? It was October. So we're going to get into some shortcuts. All right. We've been doing all derivatives for a few sections now. And we're finally going to get into some shortcuts, some ways of making derivatives go easier. All right. And so that's going to be nice. But as we get near the end of this section, we're going to see that some of the shortcuts can still be kind of long. With the product and the quotient rule specifically, sometimes we get to some messy stuff. So don't worry. It's not all sunshine and roses. You won't be bored. There'll still be a little bit of a challenge in this section. So let's start with two rules that we kind of already know. One of them we kind of already know. The other one might be kind of new. All right, so we're going to start with something that's known as the constant rule. And the constant rule says that if you're taking the derivative of a constant function, well, derivative is slope. What is the slope of a constant function? A constant function is constant. It's flat. The slope anywhere on the constant function is always 0. So the derivative of a constant function is 0. All right, we're also going to have the power rule. This one is maybe the most famous result. This says that the derivative of x raised to any power is the exponent times x, but now the power gets subtracted by 1. So this power rule is very, very, very famous. There's a cool little proof. The proof of this rule is pretty easy. You just look at the limit definition of the derivative, and for a constant function, that derivative is always going to be 0. Proving this, the derivative of a monomial, or even with fractional powers and negative powers, this one's a little bit more involved. It requires the binomial theorem, but it's not too bad. It's in the book, but I'm not going to be doing it here. I thought about it. This is true for any n. Let's just do some examples. Let's just use these. Example 1. Find the derivative part A. F of x equals the constant function at 8. So the function is always equal to 8. Doesn't matter your input. So it's a flat line. We can use the constant rule. Say, okay, f prime of x, what's the derivative at any point? The derivative, the slope of the function at any point is 0. That's it. That's the constant rule. There's nothing you can really do with the constant rule to make it more exciting, I don't think. Derivative of a constant function is 0. We could do some more of those, but let's do some messier examples. Let's use the power rule. So first off, identify, yes, power rule applies here. G prime of x, and this is a notational thing that we haven't done too much, but G prime of x, that's the derivative of g of x. Okay, so n is just 3. So using this formula, it's n, which is 3, n is 3, so that's in the front, times x to the n minus 1, n is still 3, it's 3x squared. That's how you use the power rule. Let's do some more. Part C. That's all we're doing in this video. H of x equals the square root of x. And again, we're going to use the power rule, which says that the derivative, I'm just copying this down again so we can refer to it without me having to go to the previous page. And you might say, Jason, we can't use the power rule here. These aren't the same thing. Oh, but they are. Remember, radicals are exponents. This is x to the 1/2 power. So the derivative h prime of x, what is our n value here? N is 1/2. So use that formula. It's n, that's 1/2, times x to the n, which is 1/2, minus 1. Well, now it takes a little simplifying. 1/2 minus 1 is -1/2. Well, that's 1/2 times 1 over x to the positive 1/2. Remember what negative exponents do? Negative exponents. First off, the exponent is only attached to the x. It is not attached to the 1/2. And that negative exponent means reciprocal. So that's why we were throwing that x into a denominator. Well, we can combine the fractions. And again, x to the 1/2 is still the square root. So this is the derivative of the square root of x. Let's do two more. F of x equals the reciprocal function, 1 over x. And again, this doesn't look like it's in the right form. We should be looking for the derivative, to use the power rule, of x to some exponent. But it's not written in this format, so we need to rewrite this function. Rewrite f of x before we can even take the derivative. This is x to the negative first power. Negative exponent means reciprocal, and now we have it in the right form, where n is equal to -1. Power rule says the derivative, bring the exponent down, and then subtract 1 from the exponent. That's -1 times x to the -2th. It's -1 over x squared. And that is indeed the derivative of the reciprocal function. The derivative of the reciprocal function, the slope of the reciprocal function, is the negative reciprocal squared function. Let's do one more for good measure. Really toss everything in together. 1 over the cubed root of x to the 7th. In order to use the power rule, we have to write it in the right form. So remember rational exponents. Oh, we can kind of all... The exponent is the numerator, and the index is the denominator. And then again, that means it's -7/3, and we can use the power rule here. G prime of x equals -7/3. Same exponent, minus 1. 1 is the same as 3/3. We get -7/3 times x to the -10/3. Or again, we could rewrite it as before. This is -7 over 3 times the cubed root of x to the 10th. It's actually a little hard to write this. 3 times the cubed root of x to the 10th, like so. That's the power rule. That's the constant rule. And that's this video.